Essay on Relative Gravity, Using the Mechanics of Object-Oriented Science, in review. Theory is theory by design. Object-oriented design allows theory to be extendable. Orion Daly's revolutionary new theory of relative gravity explains in an object-oriented way how the universe is put together. The fundamental universe is viewed like a plasma of alternating currents. Symmetry is conserved through polymorphism of inherent properties. Given a wavelength of some deep time, symmetry in properties is not at the exclusion of randomness. As derivatives, the four known forces, the electrostrong and weak, electromagnetism and gravity, are considered to share symmetry where differentiated by their context. The relationship of dark and light matter is seen as that of impedance, where particles to galaxies, or any other body between, are first viewed as manifolds having common and inherent properties. Particles can have opposite charge, and harmonics of vectors for strings with wavelengths subject to distortion. Bodies are considered skewable and cumulative with respect to others within their context. Gravity is viewed as their fundamental relationship through superposition. The theory suggests that the universe operates like an alternating current, AC system, analogous to an alternator in a car or a power utility provider. This view imagines the universe as a vast plasma of alternating currents, an electrolytic stew, where energy and forces flow in cycles, similar to the flow of electricity. In this model, the fundamental forces of the universe can be understood as currents flowing through a dynamic medium, influencing and shaping the behavior of particles and energy. The alternating currents signify an ongoing process of charge exchange, flow, and energy transformation, which could be the key to understanding universal processes on both large and small scales. Symmetry and polymorphism in evolution. The theory also incorporates the idea of symmetry in the evolution of the universe. It suggests that symmetry is conserved in the properties derived from the fundamental currents. The properties of the universe evolve through polymorphism, meaning they can take on different forms depending on the interactions of the underlying currents. This evolutionary process is shaped by the currents and forces at play. In this framework, the universe evolves in patterns that are both symmetrical and random, allowing for the development of diverse properties and forms. Randomness, in this case, is not a complete negation of order, but rather a way of introducing variation within an underlying symmetrical framework. Symmetry and randomness, a dynamic relationship. The relationship between symmetry and randomness in this theory allows for a flexible and adaptable universe. Consider, for example, the lighting of a light bulb. It depends on the flow of current, but the exact moment at which current flows may seem random, yet it still adheres to the overall symmetry of electrical currents. The same principle of symmetry governs opposite-charged particles, which can interact with one another in ways that maintain the overall balance and equilibrium of the system. Absolute zero and the harmonics of strings. In the pursuit of absolute zero, the theory introduces the idea that the same symmetry that governs particles and charges can also extend to strings, which, in theoretical physics, are considered the fundamental building blocks of matter. These strings are not static, but can have harmonics, akin to the vibrations of a musical string, allowing for a rich diversity of states and behaviors. The symmetry of strings underpins their oscillations, creating a dynamic system where the interactions of particles and forces can be modeled as resonant frequencies or harmonics within a larger cosmic system. Conclusion: a new framework for the universe. While this theory may seem unconventional and controversial, it offers a new lens through which to understand the universe. By viewing the universe as a network of alternating currents and integrating symmetry and randomness, the theory proposes a dynamic and evolving cosmos where forces, particles, and energy are interconnected in a complex web of relationships, continuously shaped by the underlying currents of existence. Common and inherent properties of force, a unified theory. The theory of relative gravity proposes that the relationship between dark matter and light matter can be understood in terms of impedance. This analogy frames particles, galaxies, and any objects in between as manifolds, geometric structures that carry common and inherent properties of force. These properties are viewed as interwoven, allowing for complex interactions across various scales, from the smallest particles to vast cosmic bodies. Particles and harmonics, opposite charges and string vectors. In this framework, particles may have opposite charges, yet still be harmonically related through strings. The concept of strings is akin to the vibrations in a medium, where the forces between particles can be interpreted as oscillations or waveforms. These oscillations are vectors that interact, creating harmonics, patterns that are part of the larger continuum of forces. Wavelengths, time, and transformation. The theory suggests that wavelengths, whether associated with light, gravity, or other forces, can undergo distortion in time. This distortion does not erase the inherent properties of the waves. Rather, the properties are retained and transformed across time. In this view, time itself is a dynamic, derivative property. Time can produce other time, further influencing how forces and particles interact. This perspective allows for bodies to be skewable and cumulative with respect to each other, suggesting that their interactions are influenced by their relative positions and frames of reference. Gravity, in this context, is not just a force of attraction, but is defined by the relationship of bodies to each other in superposition, meaning that the influence of one body can overlap with another, creating a complex network of forces that affects the behavior of everything in that space. The four forces, a unified spectrum. In this theory, the four fundamental forces, electromagnetic, strong, weak, and gravitational, are seen as interconnected and relative to one another. Each force, while unique in its effects and characteristics, is part of a larger spectrum of relative force, with symmetry shared through a fundamental property that transcends their individual natures. Symmetry and differentiation of forces. The forces are differentiated by context, specifically how they manifest in space, time, and matter. The electromagnetic force, for example, governs interactions between charged particles, while the strong and weak forces are responsible for atomic nuclei and fundamental particle interactions. Gravity, on the other hand, governs the large-scale structure of the universe. Despite their differences, these forces share a symmetry. They can be seen as parts of a unified spectrum, akin to the spectrum of light. Just as light can be split into its constituent colors, red, orange, yellow, etc., the four forces can be viewed as different manifestations of the same underlying property. The forces can blend and coexist in space, influencing matter in intricate ways. The four forces as a spectrum. To visualize this, consider white light. While we perceive it as a single entity, it is actually made up of a mixture of wavelengths, each representing a different force. In the same way, the four forces of nature could be thought of as distinct but interrelated components of a unified spectrum of relative force. These forces exist simultaneously, blending and interacting within the context of space and time. The example of a drop of water in space. To bring this theory into a more tangible context, consider a drop of water in space. This drop, like any object in the universe, contains all four forces. The way these forces are blended determines the properties of the drop, and thus its behavior within space-time. The interaction between gravity, electromagnetic forces, and the strong and weak nuclear forces shapes the nature of the object, its energy state, and its interactions with other objects. Conclusion: the unified concept of force. Ultimately, this theory proposes that the universe operates with a unified understanding of force, a concept that sees the four fundamental forces as related, part of a broader spectrum of relative forces. Through this lens, objects, particles, and galaxies are not just subject to isolated forces, but are part of a larger, dynamic system, with forces blending and interacting in ways that shape the evolution of the universe. In essence, the theory suggests that gravity, electromagnetism, the strong force, and the weak force are not distinct phenomena, but rather manifestations of the same underlying principles of relative force that govern the behavior of all matter and energy in the universe. Spatial time, a continuum of waveforms and reference frames. In the theory, the universe can be thought of as a sinusoidal waveform, a continuous oscillating cycle that represents spatial time. This framework allows for an expansive range of scales, where the wavelengths of cosmic events can vary from the smallest distances, nanometers, to the largest, billions of miles, and the cycles of these events can range from trillionths of a second to billions of years. Waveform of the universe, expansion and contraction. On this cosmic waveform, the universe's expansion and contraction could be represented as the opposite extremes of the waveform, where one side symbolizes the expansion of space-time and the other symbolizes its contraction. This oscillation could offer insight into how gravity and its relation to light interact in the grander picture of the universe. Essentially, It suggests that both gravity and light are woven into this continuous fabric of spatial time, each influenced by the oscillations of the universe's expansion and contraction cycles. Time as a derivative, spatial time and asynchronous reference frames. Time, in this context, is seen as a derivative of spatial time, rather than a constant measure. The idea of alternating current, AC, can serve as a metaphor for the relationship between time and space. Just as alternating currents in electrical systems represent a flow that shifts direction periodically, spatial time can alternate, giving rise to asynchronous reference frames, different perspectives of time and dimension depending on one's position in space. Each reference frame, e.g. a planet, a solar system, a galaxy, represents its own version of time, which can be thought of as a present that is relative to other frames. This view suggests that time is a matter of perspective, with each frame experiencing time differently based on its own past, present, and future. The interactions between different reference frames allow for the concept of synchronistic events, where multiple frames synchronize over time. These events could occur when two or more frames share a common connection or effect, even if their internal timescales and dimensions are asynchronous. Synchronistic events and the infinite quanta of probability. A synchronistic event between multiple reference frames, such as different galaxies, solar systems, or planets, can be seen as infinite in its quanta of probabilities. This means that these events, while potentially infinite in their possibilities, share a kind of interconnectedness that transcends their individual temporal and spatial limitations. The interconnectedness might emerge due to a collision, impedance, or superposition, all phenomena that create synchronized effects across vast distances. These synchronistic events indicate that the universe itself is not static or unchanging, but rather a dynamic, interwoven network of possibilities, where time and space shift and synchronize in infinite ways. The dark fabric, a network of black holes and alternating currents. In this view, the dark fabric of the universe is composed of black holes that act like alternators within the spatial-time continuum. Each black hole could be seen as generating its own oscillating field, essentially contributing to the cosmic alternating current that weaves the fabric of the universe together. This idea echoes Stephen Hawking's assertion that there may be 100 million black holes per cubic light-year in the observable universe. The dark fabric is characterized by infinite probabilities, as the black holes within it continually interact with the space-time around them, creating alternating currents of energy, matter, and gravity. The speed of light could play a central role in how these black holes and their gravitational waves propagate through the universe, weaving together the vast cosmic fabric at the scale of the universe. These black holes are not merely isolated phenomena, but are woven together through spatial time via their alternating currents, creating a network that transcends the individual properties of any single black hole. The resulting structure could be a dynamic, interconnected system that shapes the overall structure and evolution of the universe. Conclusion: the universe as a unified, oscillating continuum. In this theory, the universe is viewed as a dynamic continuum of spatial time, where time and space are in constant flux, expanding and contracting in cycles. The four fundamental forces are woven into this continuum, with gravity and light serving as integral components that influence the behavior of matter and energy. The dark fabric, composed of black holes and their alternating currents, acts as the medium through which the cosmic forces interact and synchronize across vast distances. This view offers a novel perspective on the interconnectedness of time, space, and gravity, where the universe is not just a collection of isolated bodies, but an intricate, oscillating web of interacting forces and probabilities. The Uniform Relative Force Model, URF. The Uniform Relative Force, URF, is a key conceptual framework within the theory of relative gravity. It serves as an abstract model to describe how particles, matter, and even galaxies are held together within the fabric of space-time. The idea behind URF is to find a common, unified force that connects the different aspects of gravity, electromagnetism, and the nuclear forces, strong and weak, offering a way to describe how these forces can exist in relation to one another. Conceptualizing uniform relative force. The uniform relative force, URF, is conceptualized as a manifold, where different forces, electromagnetic, gravitational, strong, and weak, can be understood as part of the same spectrum of forces, differentiated only by their context in spacetime. Just as particles, matter, and galaxies are held together by an invisible force, the model imagines the forces acting on different scales, whether atomic or galactic, through a shared property of relative force that links them. This creates a consistent framework for understanding the interplay between different types of forces. In this framework, URF could also be compared to a voltage in a way analogous to the principles of Ohm's law from electrical theory, which relates voltage, current, and impedance. By this analogy, URF represents the potential force acting on a system. It is not a single uniform value, but rather varies depending on the context, such as the scale or reference frame of a given interaction. Analogies with Ohm's law. Impedance. Just as Ohm's law describes how electrical impedance affects the relationship between voltage and current, the concept of URF applies a similar logic to how different forms of matter and energy interact within the universe. Impedance here could be seen as the contextual resistance that governs how forces act upon different bodies, particles, atoms, or galaxies. Voltage as URF. The voltage in this analogy represents the potential force within a system. In the context of relative gravity, this potential can manifest as gravity at the galactic scale, electromagnetism at the particle scale, or other forms of interaction at varying distances or energy levels. Just as a higher voltage can drive a more dispersed current, different forces, like gravity or electromagnetism, can be understood as manifestations of URF, depending on the scale and context. For example, in dark matter, URF could explain its effect on cosmic structures and galaxies, despite it being undetectable through traditional means, i.e., electromagnetic radiation. Even though dark matter does not directly emit or reflect light, it still plays a crucial role in gravitational forces on the cosmic scale. In this way, URF provides a framework for understanding dark matter and spatial bodies as equivalents in the broader model of relative mass. Contextual differences, current and impedance. In electrical circuits, voltage is related to current and impedance. By analogy, URF's role can be viewed as representing a unified force that, depending on the context of the system's impedance, e.g., the specific conditions of a gravitational field, electromagnetic environment, or nuclear interaction, determines how it manifests across different scales. For instance, in gravity, the impedance might represent the curvature of spacetime around a massive object, whereas, in electromagnetism, it might correspond to the medium through which the electric and magnetic fields propagate, such as a vacuum or a conductive material. Thus, while URF itself is constant as a force across these contexts, the way it is expressed can differ based on the impedance or resistance to force propagation inherent in the environment. The unification of the four forces. The uniform relative force URF model provides a potential pathway to unify the four fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces. According to this model, these forces, while distinct in their individual properties, share a fundamental symmetry when viewed through the lens of spatial time. This means that they can all be understood as different expressions of the same underlying force, with the distinction between them arising from their context in space and time and their respective impedances, or resistance to transmission. Electromagnetic force acts between charged particles and is mediated by photons. It governs interactions between atoms and molecules, shaping the structure of matter. Gravitational force acts between masses and is mediated by gravitons in the context of quantum gravity. It shapes the structure of large-scale objects like planets, stars, and galaxies. Strong nuclear force acts within atomic nuclei, holding protons and neutrons together, and is mediated by gluons. Weak nuclear force, responsible for radioactive decay and other subatomic processes, mediated by W and Z bosons. Each of these forces, under the uniform relative force model, can be seen as a unique manifestation of the same relative force, which, depending on its specific context, will behave differently. However, the model suggests that at a deeper, unified level, they are interconnected and share an intrinsic symmetry that ties them together within the structure of the universe. Dark matter and spatial bodies as equivalents. In this framework, dark matter can be viewed as an equivalent to ordinary matter in terms of relative mass, despite its lack of direct interaction with light. Just as electrical current and voltage are interdependent, dark matter and spatial bodies, like galaxies, can be seen as part of a larger dynamic system, both influenced by URF in different but related ways. The concept of URF thus provides a conceptual basis for understanding how dark matter, visible matter, and force interactions are interconnected, despite appearing different at first glance. This conceptual unification offers a pathway toward understanding the cosmic scale interactions of forces in a manner that may eventually help reconcile different forces within a single theoretical framework. Conclusion. The Uniform Relative Force, URF model, suggests that the four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, can be understood as different expressions of the same underlying force, depending on the context of the system in which they operate. By relating these forces to concepts from electrical theory, such as voltage, current, and impedance, the URF framework offers a unified view of how forces interact across the universe, from the smallest particles to the largest cosmic structures, all held together by the shared property of relative force. Polymorphism and the principles of the delta phenomenon. The concept of polymorphism in this abstract model is applied to the unification of physical laws and the nature of entities in the universe. It proposes that entities, whether particles, bodies, or larger systems, undergo transformations and cycles in ways that preserve and express their properties through varying states, much like an alternator generating alternating currents. This dynamic is formalized as the delta phenomenon, a model that describes how an entity exists across different states, both in time and dimension, with a focus on the cyclical evolution of these states. Key principles of the delta phenomenon. 1. The basis of dimension in a body. The delta phenomenon serves as the fundamental basis of dimension that underlies all entities. It proposes that the physical properties of bodies and systems are not fixed in a singular state, but are instead subject to transformation, allowing them to exist across various states of being. Second, existence in prior and future iterations. For an entity to be observed in its present state, there must also be a prior and future iteration of that entity. If an entity exists at a given moment, its history, prior iteration, and potential future iteration, must also be considered. The current state of an entity cannot be fully understood without accounting for its existence across time. Third, family of entities and unique personifications. The delta phenomenon applies to both singular entities and families of entities, where each may exhibit a unique manifestation of the phenomenon. However, despite these unique expressions, they remain part of the same underlying delta phenomenon. This means that different entities or systems, though varied in their specific characteristics, still share a common underlying principle of transformation. Fourth, parallelism and symmetry. Across entities. Even though entities may be unique in their manifestation of the delta phenomenon, they parallel each other through the symmetry of their cyclical nature. This allows for the establishment of points of reference between different categories of existence. The uniqueness of one entity or system is linked to the others through the principle of symmetry, where even radically different systems can share structural parallels, thus making comparisons or correlations possible. Application of principles in evolution. These principles can be viewed as an object-oriented model for evolution, where the evolution of entities, whether they are particles, organisms, or galaxies, is understood through the lens of polymorphism. Polymorphism, in this sense, refers to the ability of an entity to express different states or forms across time, all while maintaining a coherent identity or set of properties. Cyclic paradigm. The principles function in a cyclic manner, similar to Mandelbrot sets or the Sierpinski triangle. These fractals repeat in self-similar patterns at different scales, and the principles of the delta phenomenon similarly repeat in cycles. The progression of these principles follows a pattern from principle 1, establishing the basis of dimension, to principle 4a, establishing symmetry and reference across entities, then back to principle 1 as a new cycle of differentiation. Inheritance and differentiation. The polymorphism of entities occurs through inheritance of properties from earlier stages in the cycle. As an entity undergoes differentiation through time and space, it retains properties from its previous iterations, and these properties evolve as the entity progresses through each stage. Linking to Weinberg's singularity and scientific law. The model proposes that polymorphism offers a reasoned framework for understanding the singularity concept, similar to that of Weinberg's singularity in physics. Traditionally, the Big Bang is considered the beginning of the universe, but polymorphism does not assume this as an absolute starting point. Rather, polymorphism allows for the possibility of multiple beginnings and cycles of transformation within the universe. It makes the idea of a Big Bang plausible, but also opens up the possibility of many such events, each occurring as part of the ongoing cycles of the delta phenomenon. In this model, observations of truth, through scientific law and experimentation, are critical, but the polymorphism allows for a conceptual framework that goes beyond pure observation. It provides reason for why properties are conserved and can be inherited across cycles of time, facilitating unification across the different physical laws of the universe. Conclusion: a unified cyclical model of the universe. The delta phenomenon provides a powerful conceptual tool for understanding the evolution and unification of forces in the universe. Through the framework of polymorphism, entities are seen as existing across time and space in cyclical patterns. This allows for the possibility of multiple origins, like the Big Bang, but without assuming that any single event is the sole beginning of all existence. Instead, polymorphism creates a flexible, evolving model that preserves the core properties of entities while allowing for their transformation across iterations, ultimately offering a cyclical and unified model of how the universe functions. Applying the theory of relative gravity and the delta phenomenon to the Big Bang. In the context of the theory of relative gravity and the delta phenomenon, we can reframe the Big Bang not as a singular one-time event that marks the beginning of the universe, but rather as a cyclical process within a larger polymorphic framework. This approach challenges traditional cosmology by suggesting that the Big Bang could be just one iteration in a cycle of universe creation, transformation, and evolution. Here's how the delta phenomenon can be applied to the Big Bang. 1. The Big Bang as an iterative cycle. In the delta phenomenon model, the universe can be seen as undergoing cyclical iterations, where each cycle represents a state of existence in a continuous and evolving system. The Big Bang could be viewed as a recurrent event in a sequence of iterations. The explosion of the Big Bang would represent one iteration of the universe's existence, where an immense amount of energy, space, and time suddenly emerges from a singularity. However, instead of being the beginning of everything, it would be a moment in an infinite series of cosmic cycles. Each cycle contains elements of polymorphism, where entities, such as galaxies, stars, and particles, evolve and transform over time, inheriting properties from previous cycles and passing on these properties in their own time. Thus, the Big Bang is part of an ongoing process, where the universe is constantly being reborn in different forms while retaining the essence of prior cycles. 2. The Big Bang and the delta phenomenon. The delta phenomenon suggests that entities evolve through polymorphic transformations, where they exhibit unique personifications across different states, but all share the underlying properties of the same phenomenon. If we apply this to the Big Bang, we can propose that the Big Bang represents an instance of transformation within the broader continuum of universal cycles. This transformation can be broken down into several key principles from the delta phenomenon. Principle 1. Basis of dimension in a body. The Big Bang would not represent a sudden appearance of dimension or space, but rather a shift from one-dimensional state to another, in which the universe expands from a singularity into a multi-dimensional reality. The expansion of the universe, as seen in the Big Bang, could be understood as the manifestation of dimension in a new state of existence, inheriting the properties from the previous iteration of the universe. Principle 2. Prior and future iterations. The current state of the universe, as manifested by the Big Bang, cannot be fully understood without acknowledging its past iterations, prior Big Bang events, and its future cycles, the eventual collapse or transformation into new forms of existence. Each Big Bang might be one iteration in a cycle of cosmic rebirths, where the universe contracts, reaches a singularity, and then expands again. The idea of prior and future iterations highlights the continuity of existence across cosmic cycles, even though the specific physical forms change with each iteration. Principle 3. Family of entities and unique personifications. The Big Bang represents one of many iterations in the life of the universe. In each cycle, entities such as galaxies, stars, and matter undergo transformation, maintaining a unique personification of their properties, yet all sharing a common origin in the cyclical nature of the delta phenomenon. Just as a single entity can undergo polymorphic transformations, the universe itself cycles through different forms and dimensions, retaining its inherited properties while evolving over time. Principle 4. Parallelism and symmetry. Despite the apparent uniqueness of each Big Bang event, there is symmetry in the recurrence of these events. This symmetry implies that even as the universe undergoes transformation from one cycle to the next, there are underlying patterns of reference that tie the cycles together. The Big Bang might look different in each iteration, due to different states of matter or energy, but the fundamental nature of transformation, the expansion from a singularity, the formation of matter in space, and the eventual evolution toward a new state, remains consistent across cycles. This symmetry is rooted in the delta phenomenon, which allows for the continued transformation of entities and forces while preserving certain invariant properties. 3. The Big Bang is a part of a larger polymorphic universe. In this framework, the Big Bang is not an isolated or singular event. It is a moment in a much broader polymorphic system, in which the universe undergoes repeated cycles of creation, transformation, and dissolution. These cycles are interconnected and driven by the continuous inheritance of properties from previous iterations. Inheritance of properties. The properties of the universe in the current Big Bang event are inherited from previous cycles. Matter, energy, space, and forces do not emerge from nothing but are recycled in a cosmic process that ensures continuity across time and space. Each cycle contributes to the formation of new systems and structures within the universe, carrying forward the foundational characteristics of the delta phenomenon. Polymorphism of forces. The four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, are expressed in the Big Bang as a unified force, undergoing transformation as they evolve through different states of the universe. The forces are viewed as having a relative relationship to each other within their context in time and space, a reflection of their polymorphism within the universe's larger cyclical process. 4. The Big Bang and the continuity of time. In the delta phenomenon, time is not a linear progression, but a cyclical phenomenon, where each iteration of the universe contributes to the continuity of time. In this view, the Big Bang marks the beginning of a new cycle in the flow of time, but it is not the first instance of time itself. Time, like matter and energy, is inherited and transformed across each iteration. Spatial time and reference frames. Time within the universe is seen as relative to the specific reference frames of entities. The Big Bang could be interpreted as a shift in reference frames, where the universe begins anew in a new context, with each entity evolving its own perception of time based on its state in the universe. The expansion of the universe after the Big Bang can be thought of as the opening of new reference frames, each with its own unique progression of time. Conclusion: the Big Bang as an iterative event. In the context of the theory of relative gravity and the delta phenomenon, the Big Bang is not a singular origin, but one iteration in a cyclical universe. Each cycle of the universe is a transformation, where properties of energy, matter, and time evolve and are inherited across iterations. The delta phenomenon allows for a view of the Big Bang as part of an ongoing, eternal process of universal creation, where the universe's laws and forces are not fixed, but subject to polymorphic transformation, retaining essential properties while evolving across cosmic cycles. In summary, the delta phenomenon and theory of relative gravity can reframe the Big Bang as part of a cyclical process, rather than a singular event. In this view, 1. The Big Bang is one phase in an infinite cycle of cosmic creation, transformation, and rebirth, with each iteration inheriting properties from the last. 2. The universe's forces, dimensions, and entities evolve through polymorphic transformations, keeping some core characteristics while expressing them in unique ways across cycles. 3. Time is not linear but cyclical, and the Big Bang marks the start of a new reference frame within an ongoing sequence of iterations. 4. The symmetry and continuity of these cycles suggest a deeper cosmic pattern, where the universe constantly redefines itself while conserving fundamental properties. This approach ties the Big Bang to a broader eternal model of universal evolution. The mechanics of a black hole. The mechanics of a black hole can be theorized to be like a spatial induction engine. Consider a vibrating flat disk similar to an audio speaker and microphone. The black hole, if to consist of alternating currents, could vibrate in a similar way. The spatial induction engine concept, when applied to a black hole in the framework of relative gravity, presents a fascinating way of understanding how black holes might